Let us study an important phenomena in reflection by spherical mirror, that is paraxial incident rays on a spherical mirror. You must understand what do we mean by paraxial incident rays, because in whole geometrical optics, when we are going to study about reflection of light by spherical mirrors, we'll always consider light rays as paraxial incident rays, because all the mathematical rules we are going to use in reflection and image formation are used and defined for paraxial rays only. So first we'll write down what do we mean by paraxial incident rays. Here we can write incident rays which are very close to principal axis of mirror are called paraxial rays. And we can also write one thing, that only paraxial rays incident on spherical mirrors which are parallel to principal axis pass through focus after reflection. Like if we talk about a concave mirror, if this is the focus point and this is the center of curvature, and we have studied that focus point is located at a distance f which is equals to r by 2. If a light ray which is very close to principal axis and parallel to it after reflection, we can say that the light becomes converging and will pass through focus. And if a light ray is incident on the mirror which is coming at a distance far away from principal axis, then geometrically it is seen that when it follows laws of reflection, after reflection it passes through a point which is between the pole and focus. This light ray will not be considered as a paraxial ray. Only paraxial rays are considered to pass through focus if these are initially parallel to principal axis. And similar to the situation, if we talk about a convex mirror and this is the principal axis, this F and this C point, and the situation if a light ray which is very close to principal axis, which can be considered as paraxial ray, after reflection it will pass through focus. And if a light which incident onto the mirror which is far away distance from the principal axis, it is observed that after following the laws of reflection, it is reflected in such a way that it appears to pass through a point which is between P and F. And these are all geometrical defects in spherical mirrors for the light rays which are not close to principal axis, which we are going to study in detail under the section of spherical aberrations at the end of the topic of reflection and refraction of light. But right now you must keep in mind that only paraxial rays, like these two rays, we analyze the whole mathematical relations of reflection of light. Like focal point, here we are defining in terms of paraxial rays only. Those rays which are far away from the principal axis will not be treated as paraxial rays and does not pass through focus if parallel rays are incident on the mirror. So here we can write down a note that focus or focal point of a spherical mirror is only defined for paraxial rays.